Okay, our lesson today, we want to be able to use rules to work with exponents. All right. There are three general rules that we're going to be working with today. First, the product of powers property, which says simply when we multiply powers with the same base, we're going to add their exponents. For example, if we have 4 to the second power times 4 to the third power, notice that the base is the same and we're multiplying. So this is an example of multiplying powers with the same base. We're going to add their exponents. So 4 to the second power times 4 to the third power is the same as 4 to the 2 plus 3, which is going to be 4 to the fifth power. All right. Second rule we're going to be working with is the power of a power property. And the power of a power property says that to find a power of a power, we're going to multiply the exponents. So if we start with 4 to the sixth power and we want to raise that to the third power, that's the same as 4 to the sixth times 4 to the sixth times 4 to the sixth, right? Which is the same as 4 to the sixth times 3, or 4 to the 18th power. And then the last rule we're going to be working with is the power of products property. And that property says to find a power of a product, we have to find the power of each factor. All right. So if I have 3 times 2 to the fifth power, that's going to be the same as 3 to the fifth power times 2 to the fifth power. All right. So we're going to jump down here and take a look at some examples. All right. And the first one we're going to look at is here, right? That first rule where we're multiplying powers with the same base. And when we're multiplying powers with the same base, very simply, we're going to add the exponents. So we have 2 to the fourth times 2 to the fifth. You have to recognize that we're multiplying powers and the base is the same, right? The base is 2. And when we multiply powers with the same base, we simply add their exponents. So 2 to the fourth times 2 to the fifth, that's the same as 2 to the 4 plus 5, which is going to be 2 to the ninth power. And just so that we understand, if we write this out, right, 2 to the fourth power is going to be 2 times 2 times 2 times 2. 2 to the fifth power is 2 times 2 times 2 times 2 times 2. How many powers of 2 would we have if we multiply 2 to the fourth times 2 to the fifth? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 powers of 2. And that's where we get our product, all right? But we just want to be able to use the rules. And if we're multiplying powers with the same base, we simply add the exponents. So if we look at our next example, we're multiplying negative 5 times negative 5 to the sixth power. That negative 5 is negative 5 to the first power. Notice that the base is the same, right? The base is negative 5, so we add the exponents. So we make sure we keep that base the same, negative 5. But the exponent's going to be a 7 here. All right? And if we take a look at our next example, we're multiplying powers with the same base. We add their exponents. That's going to be x to the 10th power. All right? So very simply, that first rule we're going to be playing with, when we multiply powers with the same base, we're going to add their exponents. Now these next few problems are a little tougher, right? But we are using the rules. All right? Now, here we have negative 3x squared, and we want to multiply that by 4x to the fifth power. We want to use our commutative property to reorganize the factors here. So I'm going to reorganize that as negative 3 times the 4 times the x squared times the x to the fifth, right? So we're just using that commutative property to reorganize our factors. And now we multiply the negative 3 times the positive 4. That's going to be negative 12. And here we're going to be using that product of powers property where we're multiplying powers with the same base. We add the exponents. So that's going to be x to the second times x to the fifth. That's going to be x to the seventh power. So the product here is going to be negative 12 times x to the seventh power. All right. Next example, we want to do the same way, right? We want to reorganize our factors using the commutative property. So if we reorganize the factors here, that's going to be negative 2 times the negative 8 times m times the m to the fifth power. Now we multiply negative 2 times negative 8. That's positive 16. M to the first times m to the fifth. We're multiplying powers with the same base. We add their exponents. That's going to be m to the 6th power. So we wind up with 16 times m to the 6th power. Right? Next couple of examples, we do the same way. Right? So that's going to be negative 2 times 3 times a and times a to the 4th power. Negative 2 times negative 3 is negative 6. A to the 1st times a to the 4th, that's going to be a to the 5th power. So our product's going to be negative 6 times a to the 5th power. All right, in our next to last example, we have negative 4 times negative 6. Let's reorganize those factors. Or negative 4 times 6. We have a to the 5th. All right, we have a to the 6th. Negative 4 times positive 6 is negative 24. A to the 5th times a to the 6th. Multiplying powers with the same base. We're going to add their exponents. That's going to be a to the 11th power. So we wind up with negative 24 times a to the 8th power. All right. Right here, right, we have a lot of different factors here, so we really have to be careful when we use our commutative property. But this is going to be negative 7 times the 5, and then we have a to the 4th. And let's see, here we have a to the 1st, right, times a, and then we have b to the 1st, and that's going to be times b to the 4th, and then we have a c to the 3rd, and then we have times c to the 2nd power. All right, so we want to reorganize our factors, and now we multiply. Negative 7 times 5, that's negative 35. A to the 4th times a to the 1st, that's a to the 5th. B to the 1st times b to the 4th, it's going to be b to the 5th. And c to the 3rd times c to the 2nd, that's going to be c to the 5th power. So our product's going to be negative 35 times a to the 5th power times b to the 5th power times c to the 5th power. All right. Now we're going to move on to our next rule here. And our next rule is when we want to find a power of a power. So we're going to start off with 3 to the 4th power. And when we raise 3 to the 4th power to the 3rd power, we have to multiply the exponent. So 4 times 3 is going to give me 12. So if I'm raising a power to a power, we multiply the exponents. And that's what these first couple of examples say, right? If I have w to the 5th power and I'm raising it to the 4th power, right? And imagine it this way, right? That's going to be w to the 5th times w to the 5th times w to the 5th times w to the 5th. If we wrote out all those w's, there would be 20 factors of w, and that's where we get the product of w to the 20th power. But the rule, very simply, if we're raising a power to a power, we multiply the exponents. So let's take a look at the examples that we have here. Here we have 3 to the 2nd power, and I want to raise that to the 3rd power, so I'm going to have to multiply those exponents. That's going to give me 3 to the 6th power. But I'm raising that to the 2nd power here, so we'd have to multiply those exponents. 6 times 2 is, that's going to be 3 to the 12th power. All right. Simply put, we multiply 2 times 3 is 6, 6 times 2 is 12, and we get 3 to the 12th power. Once again, I'm raising a power to a power, so we multiply those exponents. It's going to be 2 to the 10th power, w to the 4th, raised to the 6th power, right? That would be w to the 4th times 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 w to the 4th, right? That would be 24 factors of w, and that's where we get w to the 24th power from. This last example, we have 3 to the 2nd power. That's the same as our first example. All right, so we're just going to skip down to the next page here. Right, now these problems are a little tougher, right, and we're going to have to use a couple of our rules here. Right, so here we have 3 to the 3 times x squared times y to the 3rd power, but we're raising that to the 2nd power. Now here, right, this page is a little ahead, but we have 1, 2, 3 factors. So each of those factors have to be raised to these powers. Right, and that's actually our next rule, but we'll do it anyway. So that 3 has to be raised to the 2nd power. The x squared has to be raised to the 2nd power. So x squared raised to the 2nd power, that's going to be, we multiply those exponents. 2 times 2 is 4. 4 times 3 is 12. So that's x to the 12th. y has to be raised to the second power and then raised to the third power. 3 times 2 is 6, times 3 is 9, so that's going to be y to the ninth power. But that 3 squared also has to be raised to the third power, right? And I didn't do that, so that should be 3 raised to the second power times to the third power. 2 times 3 is 6, so that's going to be 3 to the sixth power. All right, and that would be our answer there. All right, now let's see. This next example here, 3/5 has to be raised to the second power, so that's 3/5 squared. 8 to the 6 raised to the second power, it's going to be 8 to the 12th. B to the ninth raised to the second power, that's going to be b to the 18th. When we're raising a product to a power, each of those factors has to be raised to that power. This next example, -2 has to be raised to the third power, and v to the 7th has to be raised to the third power. I'll put that in parentheses. V to the 7th also raised to the third power. -2 to the third power, that's going to be -2 times -2 times -2, that's -8. 7 times 3, that's v to the 21st. But then we also have what? -4 raised to the fourth power. 4 times 4 is 16, times 4 is 64. 64 times 4 is, what's that? 256. So that's going to be times -256. And that's going to be v to the 8th. All right. Now, -8 times -256. Negative times negative is positive. 256 times 8. 6 times 8 is 48. Carry the 4. 8 times 5 is 40. Right, that's 4. 8 times 2 is 16, and 4 is 20. So that's actually going to be 2,048 times v to what? Well, now we're multiplying powers with the same base. We add their exponents. That's going to be v to the 21 and 8. That's going to be 29, right? So that was a little tricky, but we could certainly handle that. All right. And let's see what we have. Oh, the last rule, which we kind of just played around with there. Should probably move my slides around a bit. But when we find when we're raising finding the power of a product, we have to raise each of the factors to that power. And that's what we were just doing here. Here I have two factors, 2 times x. So the 2 has to be raised to the third power. The x has to be raised to the third power. 2 to the third power is 2 times 2 is 4 times 2 is 8. X to the third power, right, is x times x times x. And that's where we get our product, 8x to the third power. All right. Now, here we have 3 factors in our next example, 3 times x times y. So each of those 3 factors has to be raised to the second power. So 3 is raised to the second power, x is raised to the second power, and y is raised to the second power. 3 squared is 9, x squared times y squared. All right, so let's use those rules and complete these examples here. All right, this first example, I have 3 factors, -2 times m to the 7th times n to the 6th. And we want to raise each of those factors to the 5th power. So that means we're going to take the -2, raise that to the 5th power, m to the 7th times m to the 5th. Right, when we raise a power to a power, we multiply. So that's going to be 7 times 5. That's going to be m to the 35th. 6 times 5 is 30, so that's n to the 30th. Now, if you want to multiply -2 to the 5th power, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that would be -32 times m to the 35th times n to the 30th. Right, this next example, much easier. We just have 2 factors here. But the 8 has to be raised to the second power. The b to the 9th, right, has to also be raised to the second power. 8 squared is 64. B to the 9th raised to the second power, raising a power to a power. We multiply those exponents. So it's going to be b to the 18th power. All right. The next example here, we have 3 factors. 6 times x to the 5th times y to the 11th. Each of those factors has to be raised to the 4th power. So the 6 has to be raised to the 4th power. The x to the 5th has to be raised to the 4th power. The y to the 11th has to be raised to the 4th power. 6 to the 4th power, I'm not even going to evaluate that. And when they get a little large, you don't have to. So we're just going to leave the 6 to the 4th power. But this is going to be x to the 20th times y to the 44th power. All right, and then this last example here, we have three factors, negative 5 times w to the second power times z to the 8th. And each of those three factors has to be raised to the third power. So that's going to be negative 5 to the third power times w squared raised to the third power times z to the 8th, also raised to the third power. All right, negative 5 raised to the third power, 5 times 5 is 25, times 5 is 125, so that's negative 125. W to the second raised to the third, 2 times 3 is 6, so that's w to the 6th power. Z to the 8th raised to the third, 8 times 3 is, right, z to the 24th power. All right, so those are some of the examples that we had. We've done a lot of problems here, but hopefully that was helpful, and we'll see you soon.